Hello and welcome to your first flipped classroom lesson of Math 2. So before we get started, make sure that you have either the packet printed out or a notebook ready, and of course something to write with. And I would also have a calculator. Now for this lesson, you do not need graph paper. You will need graph paper for the lesson or for the problems that we will do in class tomorrow. If you have a printer and you are able to print out these packets, you do not need graph paper. But if you're doing this in a notebook, I would highly recommend, actually I'm going to require that you have graph paper for the things that we're graphing. So to start out with, I made a short little summary sheet to show you the difference between a linear and an exponential function. These should look fairly familiar to you. So with a linear function, we have the form mx plus b, or f of x equals mx plus b, where m is your slope or your common difference. It's what you're adding or subtracting between each term. And then b is our initial value, also known as y-intercept. And the type of growth is going to be adding or subtracting, right? Between each term, you would add 2, or subtract 2, something along those lines. And a linear function looks like this, just a line. Then for exponential functions, we have f of x equals a times r to the power of x, where a is our initial value, or it is your f of x value when x equals 0. And our common ratio is what you are multiplying by between each term. The type of growth is going to be multiplying or dividing, also known as a common ratio. And then an example of an exponential function would be something that looks like this. If this explanation feels kind of confusing to you, we're going to do some problems that hopefully will solidify it and you'll be like, oh, okay, that's what she's talking about. We're going to refer back to this little chart throughout the problems. So to start out with, they gave us these function tables, all right? Number 1 says determine if the following functions are linear, exponential, or neither. If it is linear or exponential, write the explicit rule. So what they want us to do is they want to find out if these functions are changing with a common ratio or if they're changing with a common difference. If we're changing with a common difference, we are linear. If we're changing with a common ratio, we are exponential. So let's go ahead and find out. So for number 1, we're going to go ahead and figure out what the change is. So if you notice here, all of our x values are going up by 1. So that's good. That's showing us that this is just a consistent chart, and the x values are changing by 1. Now let's figure out how the f of x values, or commonly known as the y values, are changing. So first, let's check for a common difference. To find the common difference, you're going to take the term below, subtract the term above. So you'll do 12 minus 3. And I got 9. So we know we went up by 9. Let's do the next one. 48 minus 12. I got 36. So that tells us right there that this is not a common difference because they have two different differences. It's not common. So we know that this is not going to be linear because there is no common difference. So let's check for a common ratio. To check for a common ratio, you're going to do this number divided by that number. So I got 4, all right. So that tells us we multiplied by 4. Let's try the next one. 48 divided by 12. We also get 4. Okay, looking promising. So then if you went and tried, you would notice that all of these are being multiplied by 4 between each term. So since it's multiplication, we know that this is going to be exponential. And these guys here, that tells us our common ratio. Our common ratio is going to be 4. So let's go ahead they told us that if it is linear or exponential, they want us to write the rule or write the function. So if we go back up here, we know that for exponential functions, we need to use this general formula. F of x equals a r to the x. So we have f of x equals a times r to the x. So we know that our r is 4. We need to figure out what our a is. Our a is our f of x value when x equals 0. Well, when x equals 0, the function equals 48. So that tells us that our a is going to be 48. So our function would be 48 times 4 to the power of x. And that would be our explicit rule for that function. Next, let's go ahead and look at number 2. You notice each of these x values are going up by 1, so we know we've got consistent change on that end. Now let's look at our f of x values. So first let's look at a common difference. So this common difference would be 0. This common difference would be 4. And this common difference would be 8. So right off the bat, there's no common difference. So we know it is not linear. So we can get rid of that idea. Now let's try to see if it is exponential. So we'll go ahead. 1 divided by 1 is 1, so we multiplied by 1. 5 divided by 1 is 5. We know we multiplied by 5. All right, so again, we do not have a common ratio either. So no common ratio equals not exponential. So that tells us that this function is going to be neither. It's not linear because there's no common difference. And it's not exponential because there's no common ratio. Let's go ahead and try this last one. So again, our x values go up consistently, 0, 1, 2, 3, 4. Let's check for a common difference first. To find the common difference, you do the one below minus the one above. So negative 18 minus negative 12. We end up with a minus 6. We subtracted 6 to get there. Try the next one. Negative 24 minus negative 18. Again, we subtracted 6 to get there. If you notice, all of these we're just subtracting 6. So this tells us, since we're subtracting 6 minus 6, we have a common difference. And if we go up to our chart, we know that when we have a common difference, we have a linear function. So we're going to use this formula, f of x equals mx plus b. So our m is our slope, which is our common difference. We're going down by 6. We're going to have a minus 6. Our b is our y-intercept. Well, that happens when x equals 0. When x equals 0, we get a negative 12. So our formula would be f of x equals negative 6x minus 12. All right. Next problem. It says, what is rate of change? So how I want you to think of rate of change, it really is just a fancy way of saying slope. All right, and I know you guys know how to find the slope of a line. So they said, how can we find the rate of change of an equation? Well, we know that the formula for slope is y2 minus y1 all over x2 minus x1. Hopefully that formula looks pretty familiar to you. You may have also been taught delta y over delta x, or change in y over change in x. Both of those work. And that is how you find the rate of change. Now, if you're looking at a linear function, a quick way to know the rate of change is just m. So if we look up here for number 3, this was a linear function. Our rate of change would have been -6. All right, so last 2 problems on the warm-up. These are distribution problems. They want us to simplify these expressions. So hopefully distribution is semi-familiar to you. You know you have to distribute when you have a number that is right next to a parenthesis. A counterexample of that would be like if you had -4 plus 5x minus 3. Since this 4 is not right next to that parenthesis, you do not distribute that. All right, but in this case, our -4 is right next to our parenthesis, which tells us we need to distribute to all of the terms within the parentheses. So we get -20x plus 12, and then we're done. So let's go ahead and try this next one. Now notice this one isn't just a 2, it's a 2x. So we need to distribute the 2x. So we're going to get 6x squared, since it's the x times x, minus 2x. And that would be our answer there. All right, so let's keep going. You guys are doing great. Let's go ahead and do task 1. So it says cell phones often indicate the strength of their phone signal with a series of bars. The logo below shows how this might look for various levels of service. So I'm sure y'all can look at your cell phones and you'll see those little bars. You know, they go up. It shows you the strength of your signal. So it says, let's assume the pattern continues. Use a straight edge, draw the next figure in the sequence. I'm okay with you not using a straight edge. Quite honestly, I'm going to go ahead and kind of cheat here. We know we're going to start out with this, so I'm going to go ahead and just paste it there so it looks pretty. And then we'll go ahead and we'll draw what the next bar would look like. So if you notice, we're going 1, 2, 3, 4. Well, my next one would have 5. So we'll draw our little box there. And we will make our 5 notches. So we'll go 1, 2, 3, 4 lines, which makes our 5 boxes. Number 2 says, how many blocks will be in figure 10? Discuss which strategy you used to help determine this number. So if we kind of look here, we have to go through and count up how many boxes are in each figure. Well, in the first figure, we have 1. The next figure, we have 3. The next figure, we have 6. Then 10, 15. So they want to know how many would be in box number or in figure 10. So let's go through and use this pattern. If we're adding, we have to add 1, add 2, add 3, add 4, add 5, add 6. And we'll go ahead and just make that chart. So we have the figure and the number of boxes. So in figure 1, we had 1 box. In figure 2, we had 3. In figure 3, we had 6. Figure 4, we had 10. In figure 5, we had 15. So I don't want to draw out the boxes. We're just going to use this pattern, right? We did plus 2, plus 3, plus 4, plus 5. We need to do plus 6, all right? So for plus 6, we would get 21. Then we're going to do plus 7. And we would get 28. Plus 8. We'd get 36. I'm running out of space, so I'm going to go over here. So then for 9, we'd have to add 9 to 36. You would get 45. And then for 10, right, we got to add 10. I guess I could do here, show that we added 9. And then for plus 10, we would get 55. So that would tell us that we would end with 55 blocks in figure 10. So essentially to figure this out, we just followed the pattern and made a chart. That was our method to solve. So for number 3, it says, examine the sequence of figures. Determine if the rule for the number of tiles in any figure number is represented by a linear, exponential, or some new function. What led you to this conclusion? So if we look here, we clearly don't have a common difference, right? We went up 2, up 3, up 4, so the difference changed each time. And then we could go ahead and try and figure out the ratio. So then the ratio between these first two would be times 3. The next one is times 2. So obviously, we have no common difference. No common ratio. So this tells us it is not linear or exponential. All right. So that tells us that we have some new kind of function. Now, one thing I want to point out, and this is very important because we're going to learn about this new kind of function. Obviously, we don't have a common difference or a common ratio, but I want you to look at the change in this common difference, right? We went from 2 to 3 to 4 to 5. So there's something called a second difference. All right? This went up by 1. 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 So basically this new function that we're learning about has a common second difference. And this will be important going forward, so just make note of that. So this new function has a common second difference.